So I want to talk about solving systems of equations using a graphical method. Now, you probably have already encountered up to this point a way of solving systems of equations that doesn't require you to do any graphing, that only requires some algebra, some shuffling of numbers and symbols around. But in my class, you're going to encounter some slightly bizarre systems, let's put it that way, some bizarre systems where method of substitution and method of elimination might yield some unusual results. And so I'd like to talk about a different method that can help you to make sense of situations that may seem unusual. Okay, example, solve this system. X plus y equals 0, negative x minus y equals 1. Okay. Now, if you decide, all right, what I'm going to do is an algebraic method here. Say, for example, that I decide to take this first equation and isolate y to say that y equals, let's say, negative x from 0 minus x, both sides. Move positive x over to become negative x. If you're using method of substitution, I would then take this statement, y equals negative x, which I got from equation 1, and I would bounce over and use that in the other equation to say that now I know that every time I see y, that can be replaced with negative x. So I'll put into the second equation a negative x in y's position. Now, if I go and clean this up and I say, okay, minus a negative minus negative becomes positive, and I try and combine these like terms here, if I have a negative x combined with a positive x, those two cancel each other out completely. And I'm left with the statement 0 equals 1. Now, that's unusual because all of the variables have vanished. In this equation, there are no x's and there are no y's. So let's see if we can make sense of what's going on with this system. Okay, what I'm going to do is I'm going to go into equation number 2, and I'm going to rewrite it so that y is isolated, kind of like what I did with equation 1. I'm going to rewrite it so y is isolated. So here's equation 2. I'm just going to copy it for now. Say that I'm going to scooch y over to the right-hand side by adding y to both sides. Now I would have y plus 1 equals negative x. And then I want to isolate y, so maybe I'll get rid of that 1 on the right-hand side by subtracting 1 from both sides. And I have y equals negative x plus 1, minus 1. Minus 1 here, since we took away 1 from both sides. So what I'm going to do now is I'm going to try with reasonable levels of care to graph both equation number 1 and equation number 2 on the same axes. So here's my xy axis. Okay. Now, do you remember mx plus b, slope-intercept form? On the left-hand side here, y equals negative x minus 1. Our b value is negative 1, and that represents the y-intercept. Now, because this x has a coefficient of negative 1, every time x increases by 1 unit, the graph decreases in height by 1 unit. We have a slope of negative 1. So here is a graph of the second equation. Now compare that with the first equation. Y equals negative x. Y equals negative x. It starts at the point 0 for x. If 0 is x, then 0 is also y. So it starts here at 0, 0. And it also has a slope of minus 1. So every time I go over 1, The graph must go down 1 unit, slope of -1. So these two lines in our system are parallel. These two lines are parallel, and they will never ever cross each other, which means that there is no point on both graphs. Now let's think about that. If a point is on the graph of an equation, then that pair is a solution to the equation. So if a point were on both graphs, the pair would be a solution to both equations, and such a point would be a solution to the system. But our graphs don't share any points in common. They never cross. Because they never cross, there is no pair which makes both of these equations true at the same time. So this system has no solutions. These two lines never cross, and so this system has no solutions. Now, just to note, another way to sort of think about this and get this result is to go back to when you were trying to do this algebraically. If you get down to something like 0 equals 1, which is always false and never ever true, that's another way to conclude that there are no solutions. Now, in the problem set for today, you're going to encounter another bizarro situation where instead of getting 0 equals 1, maybe you get something like 0 equals 0. And in that situation, I would like you to try and graph the equations in your system to see if you can detect what's going on.